So we have our graph of the differential function f from negative 3 to 15, and f has a horizontal tangent at x equals 6. And we're given g of x equals 5 plus the definite integral from 6 to x of f of t dt. We're asked in part A, which is a pretty common one to see, find g of 6, derivative of g of 6, and second derivative of g of 6. So let's start off with g of 6. We're just putting 6 in for x. So we have 5 plus the definite integral from 6 to 6 of f of t dt. Well, if we take the definite integral from a constant to the same constant, what is that going to be? 0. So this just ends up being 5. Right? These are the same. That definite integral is 0. Then derivative of g of 6. Well, first let's figure out what's the derivative of g of x. If we take the derivative of both sides, over here derivative of 5 is just 0. And over here, if we take the derivative of this definite integral, remember, derivative of a definite integral from a constant to x is just going to be this function in terms of x. So derivative of g of x is f of x. So that means the derivative of g of 6 is f of 6. If we look at the graph, put 6 in, we get 3 out. So derivative of g of 6 is 3. And then the last one, second derivative of g of 6, well, that's going to be the same as the derivative of f of 6. Right? Derivative of this, derivative of this. And that means we're just looking at the slope of this graph when x is 6, and that slope is 0. They told us that there's a horizontal tangent line there.